Hi, kiddos. Okay, so this morning I have to take my daughter Vinci to the doctor for some yucky allergy testing. We're going to stick lots of needles in her. So you're going to have to be working independently today for science and social studies. So today in science, we're going to represent distance and time data on a graph. We're going to start out with a little pre-assessment so I can get a good understanding of what you already know and can do with this topic. It says every morning Tom walks along a straight road from his home to a bus stop, a distance of 160 meters. The graph shows his journey on one particular day, and we can see the journey. So I want you to take a look at everything you see there. And remember, this is a pre-assessment, and I'm going to get some information about what you know. It says use the data displayed in the graph to describe Tom's journey on the bus stop. You should include details like how fast he walked and his distance and time for different portions of the journey. I've labeled different segments of the journey with letters A, B, C, and D to help you in your description. Okay, so first up, you're going to describe Tom's overall journey from home to the bus stop. You should include details like how fast he walked. I'll fix that typo. So you're going to give me an overview of what if this was his journey represented in a graph, what was it like? And then I want you to focus on the segments. So the rest of the questions, you're going to be focusing on the labeled segments. So for question 2, it says Tom's journey labeled A. So you're only looking at the part of the journey labeled A. I want you to describe what he's doing here, what his motion is. Then you'll describe B on the next question, and then C, and then describe what he's doing at D. Okay, so again, this is a pre-assessment. Get your thoughts out and do your very best on it. It helps me see what you already know. And then this last question, based on your understanding of what you see there, could this realistically happen? Is this a realistic graph? Could this happen in the real world? Like, could you have this experience based on what you see in the graph? Okay. So after you submit that quiz, you're going to move on to the next assignment. I have to go back to module since I'm not submitting it. And the next thing on the list for today is distance time graphs. We're going to be doing this for a couple of days. So this is the day 1 assignment. So today we're going to be looking at some slug bugs. I wonder if you've ever played slug bug in the car, like slug bug red, and don't punch your little brother or sister. But today we're going to look at the journeys of some different slug bugs. So let me go ahead and open my copy. So we have a purple slug bug, a pink slug bug, a blue, and an orange. And we're going to be making a distance and time graph to take a look at what their journeys look like. So first off, I'm going to do a part of the purple one as an example, and then you can be working along with me on your copy. So I have the distance and time, the time and the distance in the graph over 5 hours, and the distance that the slug bug traveled each hour to get and then the total distance traveled. So I'm going to set up my graph. Remember, in the green box, we put in a title. So this is going to be purple slug bug distance and time. Could be distance versus time too. That's fine. Just like all the other graphs we have been looking at lately, we're going to put time on the x-axis, and it is measured in hours. And on the y-axis, we're going to put the total distance. Spell that right. And it's in kilometers. Except I need to figure out how to number my graph so that my graph is nice and spread out, and that I am using equal increments as I go across the graph. I wouldn't want to number by 5s and switch all this into 10s or something like that to make it all fit. So first off, I have for my time ranges from 1 to 5 or 0 to 5. So this is going to be 0 right here, and I have 1, 2, 3, 4, 5. So exactly enough to number just by 1. So each of the yellow boxes is going to get a number: 3 hours, 4 hours, and 5 hours. Okay. Next up is the total distance. My range is 0 to up to 300. And there are 10 yellow boxes or 10 lines that I'm going to be numbering. So I like to use a calculator to figure this out so that I don't have to do that trial and error and go back and erase. That doesn't work to number by fives, that kind of thing. Let me see if I can get my calculator on the screen at the same time. Okay, so I'm going to take my total amount. So I have 300 total kilometers, and I need to divide that among 10 lines, and it happens to work out evenly, so I can count by 30s, okay? I can't count by anything less than 30s for sure. I could count by more, but the higher I go, like if I counted by 50s, I'm going to squish my graph. So I'm going to go ahead and do 30s since it works perfectly. 30, 60... 90, 120, 150, 180, 210, 240, 270, and 300. Okay, just like on the graphs we did over the past couple of weeks, we're going to copy and paste our dots in to match up with the data. So first off, we're going to put a dot at 0 times 0, distance 0. We copy, Control-C, and then Control-V to get a copy of the purple dot. Put it right there for 0, 0. And then I'm going to copy and paste that dot again. And I'm going to put a dot at 1, and the distance was 60 based on the table. So right there. I'll copy and paste that dot. And for time 2 hours, the distance traveled was 120, and so on. I'll let you finish that graph, but I'm going to remind you how to put the lines in. So I'm going to do Control Copy, Control V. I'll drag the line over, connect it to my first purple dot, and I'll manipulate it. I can move it around by grabbing those blue little dots and attach it right there. I'm going to copy and paste that line, and it might even fit just perfectly. Oh, goodness. If you do that, just go back and undo. Right there. Okay, grab that, and I can put it right on right there. It's almost perfect. Okay. Okay. There we go. And I will keep doing that as I build my graph. You'll need to add the rest of your data to it. So that is the purple. You're going to use exact same process. Look at Ms. Ross trying to get exactly perfect. Okay. You're going to do the same process with pink. It has different data for its journey for the blue slug bug and the orange slug bug. And then on the last page, you're going to think about the data that you graphed. So first off, drag and drop the slug bugs to order them from the fastest to the slowest average speed. So based on the data that you saw, which slug bug traveled the fastest overall and which one traveled the slowest? You're going to move them over and put them in order in this line. The fastest will be at the top and the slowest at the bottom. Okay, let me go. Oh, yeah, I'm going to fix that for you. Looks like I have a little overlay right there. We don't need that. I'm going to move it off to the side. Okay, so then that works. Then you have an analysis question to answer. So you're going to compare the graphs for the fastest and slowest cars. What do you notice about the shape of the graph of the fastest car compared to the slower cars? How does the shape of the graph compare for each of the cars? What kind of line does a faster car have? What kind of line does a slower car have? Okay, so answer all of those questions for me to give me a good idea of what you understand about this concept.